Hello and welcome to today's webinar on nuSIM, the integrated SIM for IoT. My name is Jeremy Cowan. I'm co-founder of IoT Now, and it's my real pleasure to be your moderator today. Thank you for joining us around the world. This webinar has found a fantastic amount of interest, and it's brought to you with our partners, Qualcomm and Deutsche Telekom. Today, we are looking at the capabilities, the benefits, and commercial adoption of nuSIM. And if you're not already familiar with it, nuSIM is a new approach to integrated SIM technology. It's specifically developed for use in the Internet of Things where simplicity, cost efficiency, and low power consumption are all extremely important. So without delay, let me introduce our speakers today. In order of appearance, they are Stefan Kalliner, Head of UICC Development at Deutsche Telekom. A warm welcome to you, Stefan.
Thank you, Jeremy. Great to be here.
Good to have you. And Sebastiano Di Filippo, Senior Director, Business Development at Qualcomm Europe. It's really good to have you here too, Sebastiano.
Hi, Jeremy. Good to be here. Thank you.
Thank you both. Together, we're going to discuss what nuSIM is, its relevance and its importance to the IoT sector. We'll also be looking at the Qualcomm 9205 integrated solution to help reduce total device cost. And finally, we'll also examine possible IoT applications. Now, please don't forget, as usual, this webinar is being recorded, and from tomorrow, you can access the audio and the slides at iot-now.com. And later on, we'll be asking what you want to know. So we'll have two very quick polls to help us inform you. And finally, I'll be putting your questions to our panelists. So you can start sending me your questions right now. Just type them into the window on your screen, and we'll discuss as many as we can. Of course, if you're having any technical issues with audio or slides, you can also use the question window to get help from our tech support team. So without further ado, I would like to hand over to Stefan. Stefan.
Yeah, thank you, Jeremy. Welcome, everybody, to our webinar about nuSIM on Qualcomm 9205 chipset. This is actually a new sort of SIM technology which is meant to solve a couple of problems and pain points that our customers still have with SIM cards. Even though SIM cards are a proven product for about 25 years, when it comes to this segment of IoT, especially the low-end, low-cost IoT devices, where everything has to be very efficient, then the existing SIM solutions actually do not really fit. So, and this holds in terms of the form factors or the size. It's still a separate component as far as we're looking at classical SIM card. Also, embedded SIM cards are still a separate component. This is also regarding the costs. If there is a device which has an intended cost point of about $5 per device, a SIM card or a SIM element, which a total cost of ownership of about $1 is no fit. I think that's clear. The power consumption is another very important requirement. Even though SIM cards are not known to be a huge power drain within devices, if it comes to a device which has to work 5 or even 10 years with only one little battery, then any little bit of charge counts. So we feel that the existing SIM solutions do not really fit with the requirements, especially in the low cost and mass market IoT segment. There is an obvious solution, and the ultimate solution, of course, is that the chip goes into the modem, right where it belongs. So we are talking about an integrated SIM here. nuSIM is actually an integrated SIM. There is no separate SIM or eSIM component anymore. We don't have any related contacts, circuit path on the board. We don't have related space requirements. We don't have specific SIM logistics, no stock keeping, no handling, no feeding to the device. And in an integrated solution, we have a number of options to optimize functionality and internal interfaces to the point where we need them. Yeah, and at the bottom line, this is supposed to give us the best cost aspect, the smallest hardware and software footprint which is possible, the best power efficiency, and indeed, it turned out that compared to a classical SIM card, nuSIM takes in 90% less of power. This is a difference. Yeah, and all in all, this comes with maximum simplicity along the value chain. We must not forget that many of our IoT customers come from business segments where they never had to do anything with connectivity. And now they want connectivity into their devices, and we have to make it as simple as possible for them. And this is another thing where nuSIM is a great help, because it replaces a physical process by a digital process. Moving on, a little bit a deeper look under the hood of nuSIM. So we have been optimizing the SIM function. We went down to the essentials. So there is a lot of things in the existing SIM standards which are actually not needed in an IoT context. All an IoT device wants to get is connectivity. So this is the thing that we need to deliver. And anything else is just ballast. We were able to simplify nuSIM in a way that we end up with a profile size of less than 500 bytes. The profile is the set of data which comes from an operator and is then loaded onto the device to represent the SIM data set within that device. That's less than 500 bytes. If you compare that to an eSIM, as it is standardized by the GSMA, this is a factor 100 less. The nuSIM application also has a very limited size. And of course, that's implementation specific, but it should work within about 100K bytes. So that's the nuSIM application. A profile comes on top of 500 bytes. So that's the simplicity about nuSIM. Another question, of course, is how these profiles get into the device. So different from eSIM, we are doing the profile provisioning over the wire right into the production line of our customers. So this is B2B profile provisioning. It's assisted by a so-called loader application. I will come to that in a minute. And can happen at the module manufacturer or the device manufacturer. We also support bulk provisioning. So that means we can deliver profiles not only one by one, but it could be like 10,000 profiles in one go or 100,000 profiles in one go. And for the user, and that's another simplicity effect, everything is already in the device, it's activated, and it works out of the box. Well, we did not reinvent all the wheels. We were borrowing a lot from the existing eSIM infrastructure. So that means we were inheriting good parts of the technology. However, nuSIM is always a subset of eSIM. It's very much simpler, very much more to the point. But the good element here is that any eSIM data preparator, for those who are familiar with that, they are called the SMDP pluses. Any SMDP plus can serve nuSIM with only very low invest. Security is a very important point. We are working with an external partner, German TÜVIT, and they have developed the nuSIM certification and evaluation concept. It's an independent certification scheme, and indeed, only about a month ago, we were able to present the first nuSIM chipset which had received this certificate from our partner TÜVIT. Last point here is the open ecosystem, and that's a very important point because this technology is not limited to the footprint of Deutsche Telekom. We are offering this to so many partners around the world. Up to 25 partners are helping us doing nuSIM today on the supply side. This is many partners from the chip industry, from the module industry, other partners from the security side. We have partners looking at providing nuSIM operating systems. Yeah, and of course, this is also open for our fellow operators. So no matter where they are, no matter whether they are our competitors or not, this is an open technology, and we are fully aware that this can only work out in practice on the long run if there is enough of a market. On the right side, why is eSIM not a fit for a low-cost IoT? Very simply put, eSIM is a complex and expensive tool. It's a very powerful tool, by the way, but for our use cases, it is way too heavy. We look at it as a too big hammer for those small nails that we intend to serve. Think of connected flower pots or coffee mugs or whatever may come to your minds. A full-fledged eSIM with all these features and with all the infrastructure behind it is indeed a too big hammer for those small nails. Yeah, and you can hurt your fingers with that. Let me continue. Here is a look at how everything is supposed to work. So from left to right, we have the chip manufacturer, Qualcomm, we have the module manufacturer, and we have the IoT device manufacturer. So this value chain is existing with IoT for a long time, and we are not intending to change anything here. On the top side, there is an MNO, and there is the element which we call the data preparator. The data preparator is working on behalf of the mobile network operator and is creating the profiles. So in the beginning, there is a device manufacturer, and they want to get connectivity to their devices. So they select an operator. That could be us, could also be one of our competitors, and they ask the operators for a number of today SIM cards, but tomorrow nuSIM profiles. So let's assume the device manufacturer wants to do 10,000 smoke detectors. So they come to us, hopefully, and ask us for 10,000 nuSIM profiles. So we forward this order to the data preparator, and we ask them to prepare 10,000 profiles. And that's what they do. They create those profiles and put them on stock. Now back to the device manufacturer. This entity is running what we call the nuSIM loader. This is a software tool which is available from us in a reference version, but of course needs to be customized and needs to be integrated into the existing production environments. That is something that needs to be done by the device manufacturer, or at least together with the device manufacturer, because sure, we don't have the insight in all those production relevant details. Now let's assume this device is installed, it's ready to operate, and then the nuSIM loader will go to the data preparator and request those 10,000 profiles. The data preparator will take 10,000 profiles, will encrypt them individually, and send the encrypted profiles back to the nuSIM loader. The nuSIM loader stores them in its database. And then in a final step, timely independent from the delivery, the nuSIM loader connects to the target devices and downloads one profile into each target device. The target device or the nuSIM within the target device decrypts the received profile and installs the contents. And then there is a final step still necessary, which is the activation of the subscription, but this is not different from classical SIM cards. So once this is done, the devices have connectivity and are ready to go. Now, having explained this, it's time to look into a little demo. This demo, unfortunately, I only have pictures, so this is not a video, this is only pictures. But this shows the loading process between the loader application and the target device. Here is the demo setup. We have the nuSIM loader running on a standard Windows PC. The PC is connected via USB to a test board or a development board, which contains the nuSIM module in this case from Qualcomm, and the chipset, in this case from Qualcomm, inside the module. There is a little black window on top of the screen. This is the device monitor, where we can look into the device and get the status and get other information out of the device. A closer look on the device itself. So this is the dev board, Qualcomm BG95 module, inside the module Qualcomm 9205. And note the SIM holder in the bottom right corner. There, this is the place where normally the SIM would go. We have inserted a strip of paper to explain that to show that there is no SIM in this holder. The SIM is in fact in the chip right in the middle. So now starting with the demo, starting with an empty device, so there is no nuSIM profile loaded. We ask the device for an IMSI, and we get an error because there is no SIM inside, there is no IMSI. We ask the device for the SIM serial number, the ICC ID. Again, we get an error. There is no SIM, no ICC ID. Now we go to the provisioning. We start the loader application. We start the profile provisioning with the loader application, and it tells us that this is now ongoing. Profile download started, and it's loading. So this goes on for a couple of seconds, and then we get to the point that the profile download is finished successfully. And this is actually what the loader application is telling us in the indicated red line box at the bottom. Now going back to the device, and we do the same things. We ask for an ICC, we ask for an IMSI first, and suddenly, hey, there is an IMSI. We ask for the SIM serial number, and we get the SIM serial number. We ask for the registration status, and we get the information that it's registered in the home network. We have a cell ID, we have a location area, and we have an indication that it's logged into 2G. So at this moment, the device is ready to operate it. It is connected. Well, one more slide regarding the availability of everything. So based on the Qualcomm chipset, we are working with two different module manufacturers. One combination is Qualcomm BG95 with the Qualcomm 9205 LTE chipset, and these dev kits are actually available. This is exactly the dev kit that you just saw in the demo, and these are available in a sense that anybody who would be interested to have one can contact us. They could even be free of charge. We would ask a few questions, but then generally these are available. A next module that we are expecting is from Telit. This will take a little longer. We expect that for around November, and further module manufacturers are expected in the beginning of next year and in the course of the next year. So it's all going on very strongly, coming up very strongly, and going to the right direction. With that, I would like to hand over to Sebastiano for a closer look at the Qualcomm 9205 chipset.
Thank you very much, Stefan. So I will be covering now the 9205 presentation, explaining how 9205 can really offer a very powerful solution and chipset for the nuSIM implementation, leveraging the strength of the platform that can really maximize the value proposition of nuSIM for the IoT world. So just to set the scene, what we did with 9205 LTE modem, we enabled the support of nuSIM solution in the 9205 LTE chipset. And we allowed device manufacturers to port nuSIM compliant application onto the devices based on the Qualcomm 9205 chip. And the nuSIM technology is an integrated SIM technology for IoT that can allow to scale because of the strengths that offer to the ecosystem. Is a secure solution, is a simple, and it offers ease of integration to manufacturing partner, and also helps to reduce power consumption for the low power application. So nuSIM is a out-of-the-box connectivity solution where the manufacturer can really connect the device with a very simple user experience, can connect the device to the network right away without taking care of the complexity of adding the external SIM to the device itself. 9205 chip is we are trying to compare with its predecessor, the MDM 9206, which is a very successful LPWA chipset supporting narrowband LT, Cat-M, and eGPRS as well, available in more than 110 designs. And the 9205, the one that we are using now for the first nuSIM porting, is software API compatible with 9206, meaning that we can really help to expand nuSIM adoption in the IoT ecosystem, leveraging the customer base on 9206. Compared to 9206, 9205 improves power consumption, so is a 70% lower power, is a 50% smaller footprint, and also 30% lower BOM cost compared to 9206. And I will show some more details later in the presentation. 9205 is a global multi-mode, multi-band LT chip and 2G chip as well. So there's support for eMTC technology, 4G technology, narrowband IoT technology, as well as eGPRS technology. Also, it includes a GNSS receiver for satellite positioning, as well as a terrestrial-based positioning. It includes an application processor, a Cortex-A7 running at 800 megahertz for an embedded application, as well as a Qualcomm trusted execution environment for secure application and for sensitive tasks. Also, it includes flash and RAM in the same chip. So everything is integrated in the same chip. There is support for carrier-grade network protocols for IoT, such as IPv4v6, TLS, MQTT, lightweight M2M, and Quiet. We have also an IoT Cloud SDK with APIs that our customers can use to develop IoT applications. And also, we include in the same chip a DSP dedicated for sensitive function, as well as manage external sensors without waking up the application processor in the chip, in order to extend the battery life of the device and reduce the power consumption. So everything is well explained in this diagram on the right-hand side. Typical IoT application and typical IoT devices, they do require, top right of this slide, you will see, 3 different blocks in the device itself. Block number 1 is a module with a cellular modem. The block number 2, if satellite position is required, is another module or another chip with the GPS support. Block number 3 is a microcontroller that is utilizing the cellular connectivity and the GPS module to implement IoT application and maybe manage sensors. All these 3 functions are integrated in the same chip, the 9205 from Qualcomm, in order to implement and offer a number of improvements to the customer, and we'll see them listed in the next slide. So, value proposition 9205 can be summarized as follows. So, a higher level of integration in its class, in the class of multi-mode LPWA devices, ultra-low power support for long battery life, global multi-mode and multi-band support for eMTC, narrowband IoT, and the eGPRS solutions, integrated GNSS receiver for satellite positioning, hardware-based security foundations, and an application processor plus a software suite for faster development of IoT applications. So, and which are the the improvements that such an integrated solution can bring. So first, for release 14 LT Cat M1, high reliability through the support of the new release 14 features for this technology and low latency as well, also including voice support via VoLTE for IT application where voice is a plus or needed for certain functions. For MB2 technology in release 14, extended coverage and delay tolerance, which are some of the strengths that release 14 and MB2 is bringing, are also supported. And use of 2G eGPRS allow to have connectivity also in areas where LTE is not yet deployed. Let me also mention the possibility to support a wide and extended range of RF frequencies from 450 megahertz to 2.1 gigahertz, supporting more than 23 RF bands, and 450 megahertz is one of the recently adopted bands for IoT application, which is more and more adopted in some territories and markets for, in particular, smart meter use cases, even in Europe. So support of this band really helps to address this new wave of innovation in the IoT space. On power consumption, as we mentioned before, there is a 70% improvement in power consumption in other plus mode compared to the predecessor, to the 9206 chip. Also in 9205, we extended the system level cutoff voltage to support more battery types. Flexibility is important for IoT application. This is one way to address this flexibility for IoT devices. Also including an advanced battery management system to extend the battery life, still supporting the same chip. Regarding positioning, we mentioned before that we support the same chip, the GNSS engine and receiver. We are including the last generation 9 GNSS receiver from Qualcomm, supporting multiple constellation GPS. They do GLONASS and Galileo. And the combination of those 4 constellations allow the device to achieve a faster time to fix and better accuracy for the positioning. And also flexibility in the design of the device, because our customers can share the same antenna between the modem and the GNSS receiver in order to optimize footprint, size, and also reduce cost, as well as maintain the 2 external antennas. We mentioned highest level of integration in its class. This is depicted here. On the left-hand side, we have a reference module based on the 9206. Right-hand side, we have a Qualcomm 9205 reference module. As a reference, we also have this picture of a coin with a 17.9 millimeter diameter. So these explain that 9205, because of its level of integration, allows a 50% smaller footprint and more cost-effective architecture for our customers, achieved through the integrated flash, RAM, and the integration of the RF front end, as well as the integration of the GPS functions. More data points on his ability to enable much smaller and more efficient architecture for our customers. There is, through 9205 chip, 40% of reduction in the total BOM, number of components in the board, 70% reduced power consumption for selected use cases, 50% smaller size of the module, while improving the features and the performance, supporting more specs and characteristics from the Release 14 3GPP. And we are not forgetting security. The security, as the slide is saying, is a paramount for the implementation and the structure of the 9205 chip. With our implementation of security that will be described in the next slide, we support device authentication at data station in the chip, directly managed in a secure way through the building blocks of the secure system of 9205. We have and protect software, checking software integrity, and we also take care in hardware in the chip of content protection. The 6 blocks of the modem security implementation in 92.5 are listed in this slide. The first one is Qualcomm Wireless Edge Services Support, which is an end-to-end service rooted in hardware in our chip that taking care of device connection, attestation, provisioning, and feature management. The second pillar of this secure implementation in 92.5 is the Qualcomm Trusted Execution Environment based on ARM Trust Zone architecture, which is an execution environment for sensitive tasks isolated from the high-level operating system, which is the place where the IoT application can be implemented. There is an engine for hardware cryptography, which is FIPS certified, and is not sacrificing the resources of the application processor embedded in the 92.5. Secure storage and key management in hardware via OTP eFuse storage, and also the possibility to encrypt the stored information in the hardware. Secure boot is another very important pillar of the security foundation of the chip, because everyone can run authentic software in 92.5 because it runs from another root of trust. And also there is a secure debug to prevent attempt via debug interfaces to access low-level function in the execution of the code. This is well explained all the strengths security-wise of 92.5 is well explained in this slide as well. So usually the approach in the semiconductor world when it comes to security for IoT application can be the one indicated as Model 1. There is a modem or an external CPU or MCU and an external secure IC. This solution is usually costly, more expensive. It requires extra BOM, and sometimes may trigger some security flaws. A second model is the one indicated as Model 2 in this slide, where all the security is implemented in the software, in the OS. This sometimes is not the best solution because the OS might be a not secure OS. Can be easily circumventable because of the full implementation in the software. Our approach is different. We have other blocks taking care of security built in the chip itself, and the one on the left-hand side of the slide. The advantage of this approach is that the architecture is designed to be fully integrated and robust. There is no extra IC required, and resulting in BOM savings, so cost reduction of the device, and also because of the simplicity, time to commercialization advantage, while critical features can be still executed in the trust zone portion of the chip. Beyond security, also flexibility in implementing the IoT application is fundamental and is very important. That is why I'm mentioning in this slide that the inclusion on 92.5 of an application processor, a Cortex A7 processor running at 800 megahertz, also paired with a trusted execution environment where more sensitive tasks can be executed without interfering with the main execution environment. We have support for real-time operating systems such as ThreadX and iOS, and including also in the application processor and our software, a set of IoT networking protocols without having our customer to reinvent the wheel, developing themselves, integrating themselves, those networking protocols, as well as cloud APIs. We pre-integrated the most popular cloud clients and offer APIs to our customers for a seamless development experience. And this slide helped me to compare the 9206 very successful chip of Qualcomm, as we mentioned before, wide adoption in more than 110 devices, to the new 9205. So 9205 modem-wise brings more capabilities through the support of Release 14 in Cat M1 and narrowband NB2, offering, for example, higher data rates in good channel conditions, but also other enhancements as per the Release 14 features. The integrated RAM and flash can really help reduce the cost and footprint of the device. The wider extended supply range can offer flexibility to customers by supporting more battery types, while the integrated direct front end can include more frequencies, like, for example, 450 megahertz frequency, which is now demanded for specific application in several regions. Okay, and this is my last slide, just to reiterate the message that 9205 can really address many IoT use cases and applications, from spanning from city infrastructure to wearable through utility metering, smart buildings, tracking, healthcare, and application when, for example, voice is an important feature, even for LPW devices. With that said, this is all for me. That's all for me. I would like to hand over to Stefan for use cases.
And another, again, final slide also from me, to give you a few examples regarding the different applications as mentioned by Sebastiano. So here's a couple of things that we are doing at Deutsche Telekom. I try to be very brief because we have obviously received a lot of questions, so there's not a lot of time left for me. Important is that all these applications share at least one requirement out of those four above: cost efficiency, power efficiency, robustness, and size. Where at least one of these matters, nuSIM is the perfect solution. So we have this IoT service button, which is to be used in outdoor applications, the pallet tracker, the low-cost sensors for sensing all kinds of parameters, the health monitoring system. This is an athlete tracker. It's attached to a running shoe of a marathon athlete, for instance, and it's monitoring not only the position but other vital parameters as well. Yeah, and the ultimate solution when this device goes right into the shoe. And in fact, we are talking to an R&D facility. Actually, it's a university here in Germany who are looking into bringing connectivity to running shoes. And the special thing here is that the shoes are supposed to generate their own energy out of their movement. And that, of course, needs a connectivity solution which is as power efficient as possible. And this is also something where nuSIM seems to be just the right candidate solution. With that, I'm finished. Now I would like to hand back to Jeremy.
Thank you, Stefan, and thank you also, Sebastiano. Okay, we are going to have a quick couple of polls to get a better understanding of the information that you'd like from us. And we'll come to those now and then go straight to your questions, because we've had a really good number of questions in. Now, the polls are as follows. We'll run these briefly. Firstly, are you interested in more technical deep dive sessions on nuSIM and IoT applications? So, are you interested in receiving more technical deep dive sessions on nuSIM and IoT applications? That's a really strong response. And the other question that we would like to ask you, please, is as follows. Are you interested in a live SIM? Sorry, I need to close that poll. Are you interested in a live nuSIM demo? So the second question is, are you interested in a live nuSIM demo? Well, many thanks for your responses. This gives us a really helpful handle, but we have had so many questions on coming in from the audience. I'd really like to go straight to those now. So without further ado, the first question is for you, Stefan. And the question is, how would you describe the main differences to the GSMA eSIM, and do you see both solutions coexisting?
Yeah, that's a very interesting question, Jeremy. I believe the main difference between the GSMA eSIM and nuSIM is that the GSMA eSIM is a product of years of standardization work. And whoever ever had had the chance to witness standardization work, this is a really cumbersome thing to do. It takes a lot of time, is quite slow, and at the end is a compromise. A compromise, of course, a compromise because you have so many different people and companies and interests and agendas on the table, and standardization has to find a common denominator. The result of that is that typically a standardized solution cannot be as optimized as a proprietary solution. And with nuSIM, we really took the approach that we started from scratch and we thought, what is the bare minimum of functionality that is needed in an IoT context? And that gives us exactly this very optimized and to the point solution that we are able to present with nuSIM. Of course, I do see things, both solutions coexist. There is so many different use cases, so many different segments, even in the IoT sector. And if it comes to the requirements of having several profiles side by side and switching between profiles at arbitrary points in time, then of course nuSIM is not a solution. But then customers have to look into eSIM. And swallow this thing, this stone. But otherwise, for other use cases where profile switching is not needed, think of cheap trackers, smoke detectors, these kind of things. Nobody would want to switch the operator in these devices. Then nuSIM is just the right solution. Okay.
The next question is from Bernie Rieterken, and he wants to know, who needs to get certified? Is that the chipset manufacturer or the module maker or both?
I think I can answer that. It's all a combination of hardware and software. So in that case, if the chip is from Qualcomm and the software is from a third party, then both Qualcomm together with a third party have to take this combination to certification. If the same chip is used with another operating system from another source, then again, this combination has to go through certification.
Okay. Again, this is a question for Deutsche Telekom, for you, Stefan. The question is asking, is there a way to initialize a trial with you?
Indeed, there is. The easiest way is to contact myself. I'm sure my contact details can be found somewhere. If you don't want to come to me directly, then of course you can also go to our website, which is going to be shown on our last slide, or it has been shown already by Jeremy on our last slide. And there you can register. You can leave your name, you can leave your email address, and then we'll get in touch. And definitely there is a way to start a trial with us.
Okay. And the next question that I'd like to put forward is the following. What about non-terrestrial networks? Sebastiano, could you handle this? It seems that Qualcomm chip will be interesting to Marco Guadalupe, but he'd like to know about non-terrestrial networks.
Well, this is something that we as a company are exploring as well. Is not targeted by the 9205 chip. So maybe we can have a separate discussion. I can follow up directly with the webinar attendee on this one. But it's not for 9205, of course.
Okay. And another one that I'd like to put to you, which seemed to have disappeared from my screen. So for a moment, I will do without that one. Let's go to the next question. Antonio would like to know, what is the average battery life for the module? Could you help us with that, Sebastiano?
Yes, thank you for the question. The battery life really depends on the module implementation, so we cannot comment directly. We will need to involve the module partners for that, and also try to have a good understanding of the scenario in which we're going to measure the battery life of the device. What we can say, we can compare 9205 with the competition, and we can detect with the feature-wise, with same feature set, 9205 really perform better than competitors because of all the strengths that we have been implemented. The implementation of a very power efficient engine in the chipset itself, and our ability also to support 3GPP features that help extend the battery life of the device really give us a proof of the fact that in the competitive landscape, the 9205 in the case of multi-mode chip really perform well. Again, the detailed answer can be provided once we agree the scenario in which we want to measure. But for example, 9205 clearly gives a strong advantage when it comes to idle mode. So when the device is not transmitting, but is still battery operated or working in detecting some inputs from signal, 9205 can really extend the battery life of the device for several years.
Thank you, Sebastian. Stefan, could you help us with this one? Gaston Becker would like to know, it's a big picture question, what is the difference in terms of futures between nuSIM and the eSIM?
I may have answered that already. This is again a question regarding the difference between nuSIM and eSIM. And of course, I do hope that both technologies, both solutions will have a great future. And I'm convinced about that anyway. So maybe I got this question wrong. Then please, Gaston, please, if you can try again, that would be great.
Okay. The Harold Remmert has put forward the following. He says, thanks, it's a great presentation. Couple of questions. Is nuSIM integrated on the Quectel Telit modem or on the 9205? I think that was addressed during the paper, but it could do with repeating. And does the 9205 include a secure element, or is it using its ARM trust zone based security system? Sebastiano, could you help us with that?
Yes, thank you for the question, Harold. So yes, nuSIM is supported in the Quectel and Telit 9205 based module. So Quectel and Telit, they have module based on 9205 chip that are supporting nuSIM. Regarding the second part of your question, we have hardware blocks in the chip. One of them is trust zone that we utilize for the nuSIM implementation. It's not an independent secure element in the same package, but there are hardware blocks, including the ARM trust zone security system, taking care of the nuSIM functionality.
Okay. Question here from Martin Dostalek. Can you combine nuSIM for multiple communication technologies, NB-IoT, 2G, 4G, 5G, etc.? Would you help us with that, Stefan?
Yes, of course. Indeed, when we are looking at the Qualcomm 9205 chipset, it supports narrowband IoT, it supports LTE-M, which is a 4G technology, and it also goes down to 2G, all in this one chip. And of course, nuSIM is able to support all these technologies. It doesn't make a difference. For 5G, we would need, well, actually, theoretically speaking, nuSIM would fit because 5G is backwards compatible with SIM technology down to 3G. But in order to make the best out of 5G, we would need to do some enhancements to the nuSIM profile to make that fit for 5G. But that's not a big deal, and we are looking forward to come up with a 5G version of nuSIM in the next release, for sure.
Thank you. Sebastiano, could you help us with this one? A number of people have put this question in various forms. Could you just reiterate, is there any secure element needed, or is this purely a software solution?
There is no need for a secure element, and this is not a pure software solution. So we have hardware blocks. We have Trazon and hardware blocks for our secure foundation of our chip, taking care of the nuSIM functionality. So it's an hybrid solution, getting the best of the two worlds. This is including the same chip, reducing the even extra cost, reducing the footprint, the size, and some of the inefficiencies of having external designs for the secure element. It's not a software solution. It's much stronger and robust than a software solution because it's based on hardware blocks that are included in the 9205.
Okay. While I have you, Sebastiano, question here from Marco. Again, does nuSIM work only on Deutsche Telekom network? I know the answer to this, but I'd like to hear your description.
Of course not. nuSIM is a SIM technology, and it behaves like a SIM. And it does that in any network. Of course, at the end of the day, it's the subscription, the data set, which is inside the nuSIM, which determines who is the home operator. So if you're using a profile from DT, DT is the home operator, and it would, of course, work anywhere where DT has a network or has a roaming agreement. If you have the profile of another operator, then the same would work for this other operator. So it's just as versatile as any other SIM card. There is no difference, and in particular, the network side is not able to detect whether there is a new SIM in the device or a real physical SIM.
Excellent. Taking that same point a little bit further, could you answer, Stefan, what's the maximum number of operator profiles supported by nuSIM? Actually, this might be one for Sebastiano.
Yeah, okay. So there is a clear answer. The maximum number of operator profiles supported by nuSIM is 1. And that's due to the simplicity target that we're having. In almost all the IoT use cases, connectivity coming from one operator is just enough. There might be reasons to switch the profile to another operator, but that new profile would simply replace the old profile, the existing one, and at any point in time, there is only one profile on nuSIM. This is one reason why nuSIM is actually so small and so efficient.
Yeah. Sebastiano, a question here for you that, again, I think you touched on before, but it would be really helpful for clarity. Are there any special prerequisites for the Qualcomm 9205 to support nuSIM? Does it work with any module using this chip?
There are no special prerequisites. So the chipset can support nuSIM, the 9205 chipset, and device manufacturer can port a nuSIM compatible application onto modules based on the Qualcomm 9205 LTE chip, and install profiles from Deutsche Telekom, and they are good to go. So it's, the answer is no special prerequisites.
Okay, staying with you, Sebastiano. Question here from Tim Masson. We test devices, and for us, the eSIM approach has become a barrier for testing physical devices. Is there a way we can temporarily install a generic test profile and easily switch back to the provision profile when we're done?
Well,
yeah, that's a very interesting
point. Probably the question for Stefan. Please go ahead, Stefan.
Thank you. That's actually a very interesting point, and I'm not seeing this for the first time. However, it's not so easy because you cannot simply switch to a test profile and then switch back to the original profile, because there is always cryptography involved, and any profile that works on nuSIM has to come from an approved source. All the different certificates need to be in place. Otherwise, nuSIM will not install this profile. However, this problem that you're asking here, that this is actually, it exists, and it's obvious that some sort of solution needs to be found. And I can only tell you that we are looking into that. I'm not here in a position to say, hey, this is the solution or that is the solution, because that is actually not an easy thing to solve.
Okay. I was just about to ask a question, it disappeared, but I will ask this one instead. Javier Duarte says, can it be said that nuSIM is a proprietary implementation of the SGP22 consumer GSMA model? Sebastiano, would you take that one, please?
I believe Stefan is much better positioned to address the question, because this is more related to the ecosystem. Stefan, do you mind taking that?
Yes, of course. I wouldn't say that. Not at all, because a nuSIM is a different approach, coming from a different angle. We are reusing some elements out of the GSMA model. But, well, if I would want to put that in a percentage, we are like using, I don't know, maybe 20% of all the functionality that's included in the GSMA standards. So there are similarities, and we are also sharing the same profile format. However, nuSIM is, again, it's using only a subset of these profile elements that are defined for the GSMA. And that is the only way to come to a really efficient approach.
This is probably going to have to be the last question. We do have other questions still coming in, and we will put them to our speaker panel. So don't worry, if your question hasn't been answered, we will pass these to our panelists, who I'm sure we will be happy to come back to you. But for now, we have the question from Robert Unrau. Isn't OTA profile provisioning possible? Stefan, would you care to handle that one?
Yeah, good question again. This is not possible as we speak. This will be possible in the next generation of nuSIM. Currently, we're looking into B2B profile provisioning, so the profiles go right into the manufacturing line of the customer, and once they are loaded to the device, they stay there. Of course, we know there are requirements for update of the profiles over the air once the devices are in the field. We are looking at that. There is possible solutions, even when we want to maintain the simple approach with nuSIM, but there are protocols like lightweight M2M, which are optimized for constrained IoT applications. And then, if we remember that a nuSIM profile is only 500 bytes, it should be possible to include a nuSIM profile into a lightweight M2M device management message and bring that down to the target device, install that, and there we go. We have the profile changed.
Well, gentlemen, you've been very candid, very helpful, and have taken every question we've thrown at you. There are more questions still coming in. I honestly can't remember when I've seen so many questions coming in on the topic. It's fantastic. And thank you so much to our audience. But thank you, gentlemen. It's gone by too fast. I am afraid we are out of time. To everyone watching, please don't forget to bookmark the site at iot-now.com, and there you'll find the latest news, videos, blogs, reviews, interviews, the lot. And from tomorrow, of course, you can stream this webinar at the site too. But it just remains for me to say a really big thank you to our speakers, Stefan Kallina. Many thanks for your time and expertise, Stefan.
Thank you, Jeremy, and thanks to the audience for all these questions, for all your interest. And if you're further interested, don't hesitate to contact us directly.
Great advice. And my thanks also to Sebastiano Di Filippo. It's been great to have you here, Sebastiano.
Thank you, Jeremy, for having me today. Thank you very much.
Been good. Most of all, ladies and gentlemen, we want to thank you for joining us around the world. Keep safe. And we have never meant that more than we do now. From everyone here at IoT Now, bye for now.